Hello everyone, my name is Anderson Diaz. I'm a PhD student at Brescia University, and now I will present my PhD project in at least 3 minutes. I will synthesize it in a way that could be simple to all of you. So let's start. My project is predicting hub aware using experimental methods and artificial intelligence. So, have you noticed when you use a rubber to erase something that you write, or draw, it produces some debris, and those debris eventually go to the floor, and then you clean your house or your office or your laboratory, and those debris goes to the trash. Okay, it's normal. But what about a seal, a gasket, a tire? What this means? This means pollution. Actually, hub aware is one of the main sources of pollution worldwide. The environment is impregnated with microplastics, and between those, microparticles of rubber is a part of them. It is a very common material in our routines, so it is easily to find this on the environment. Rubbers are elastomers, which are normally reinforced with certain compounds that give to them magic properties. These particles do not only contain elastomers, because it is filled with other components, such as silica, sulfur, carbon black. Once those microparticles spill off from tire, for instance, they bind many other debris in the environment. In addition, it can easily be absorbed by algae and fish, so marine animals. Consequently, they are also ingested by us, easily ingested by us. Even though there is no agreement regarding elastomers, particles, ingestion, and human pathology, there is a total agreement, which are the hub aware and friction mechanisms. Rubbers are complex materials, but also their friction and wear models. This depends mainly on the rubber type, remember of the reinforcements, operating temperature, applied load, sliding velocity, and substrate roughness. Additionally, once a rubber component or part is being worn, it exhibits significant variations in texture and color and material properties. And the problem with this is that these particles are not easily seen in a crude eye. So, it is difficult also for example, scanning electron microscope to detect something, not only because those equipments are expensive and neither all universities and schools and laboratories and companies could have it, but also because it requires technical people very, very well trained. So, but in this scenario, the hyperspectral imaging technique is gaining attention because its reasonable cost and the portability of the hyperspectral cameras. Hyperspectral cameras are cameras which are not only photographing something, but also capturing the relationship between the material of what it's photographing and the light. This is the spectra of the material. So, hyperspectral camera produces 3D pictures, which are able to identify the material conditions, the material properties, conditions, aging, and maybe wear. So, what is so important? So what? E allora? E o Kiko? When we can identify conditions, aging, texture, we can maybe predict wear. So take a look on this image. We see a car in the same point of the track, with the same tires, in the same event, but at different moments. And we see almost clearly, slightly clearly, that there is a texture variation. So my project is to prepare a wear model together with hyperspectral techniques in artificial intelligence in order to build an entire model to detect rubber conditions and wear on the main rubber applications, especially tires, in order to see and identify what we don't usually see. And this is it. See you in next video.